Back for part 3 of our run. This is where we left off. We've got the mug rendering pretty decently. The camera is still kind of garbage in terms of like being too sensitive. I think that's the first thing we're gonna fix. We've got these parameters running okay. We've got pretty much most of the parameters are reactive at this point. Some of them, let's test all of them. Some of them, the bracket extension is not working. The bracket draft angle is working fine. The bracket thickness is working fine. The bracket tangent cutoff is working fine. The handle diameter is working fine. The handle offset is working. The handle length is reactive. By working, I just mean reactive. We still need to like fix these bounds for all the circular dependencies between the parameters. The bracket gap is working. The handle bracket offset is working as well. Let's bump up the bracket extension. Oh, right, that one's the one that's not working. Okay, maybe we'll just start with fixing that. Jump into VS Code. The bracket extension. We'll just search for that. The bracket extension. Here we go. Bracket extension input. That seems to be correct. Find all the occurrences of that. Millimeters to meters. Extension length. Bracket extension input millimeters. Where's the redraw mug function actually being called? Because yeah, it is being called when the bracket extension changes. It should probably be changed. Like we should just have a general purpose on input change and then call redraw mug once there. But it's okay for now. Type range. Might be because the minimum and maximum values are weird. Let's see what these are. Oh yeah, so the minimum and maximum values are both 0. So I guess the minimum of 0 does make sense, and then we'll just make the maximum 1,000 for now, just to. That should really be like an unbounded input in some ways, because there's no reason why you couldn't just slam this out, as far as you wanted. I guess it would depend on the draft angle and making sure that this portion doesn't exceed the diameter of the cup, but really, I mean, that is technically constructible. So we would want to slam the draft angle way down to like 90. Or, yeah, so that's like technically constructible. And then if we move the handle offset, we'll see the handle offset now. The maximum handle offset doesn't make sense because it's just not even letting us to get out to the extent. So we should put a watcher on the bracket extension. We're gonna have to put watchers on pretty much all of these, which means we should probably just watch the input or just react to the input instead of using a V model, but I'm kind of already committed to that pattern, so it's okay. We don't really need to worry too much about performance for this application. So we'll watch the bracket extension input, create an async function, new length, we'll call it new extension. New extension length. I like that. Then we'll just say the handle offset maximum can be set to the new extension. Yeah, we can set that to the new extension. Because again, there was some ambiguity about whether or not we actually want to allow the handle to go all the way to the edge of the bracket. I remember we discussed that before. And it just kind of feels like that could be constructible and it could be a usable design, so we'll just allow that. Okay, so we'll make that watcher immediate. We're going to fix the camera right after this because, yeah, it sucks. We made that immediate, so now the bracket extension, as this goes up, we can see that the handle offset maximum is changing too, and we can now move the handle all the way back. So now we can move the handle all the way back to the edge of the bracket, which is what we just wanted to do. And then we'll just move the draft angle down a little bit. Yeah, that looks kind of cool. This would be a neat mug, right? Another thing we could do is make the floor. We can make the ground size reactive as well, because if we make the cup gigantic, it will just quickly, absorb the ground, and the ground will disappear. But maybe the ground can be like a hint, like don't keep things kind of within this range. Let's just have fun real quick and make a really absurd. Oh, okay, so the bracket gap now. We need to have a watcher on the cup height. We need to watch the cup height. And I think there's a couple things that may be influencing the cup, may be influenced by the cup height or dependent, a couple parameters dependent on the cup height. Technically the handle height for like constructability and usability, but the biggest one is going to be the gap between the brackets. So we'll just put that one in for now, and then when we find one of those circular dependencies or something, or other dependencies on this, we will add them and see what happens when we do that. So we'll do bracket gap. So I guess the minimum is always going to be, I think, what we had it as, which is the bracket, which is 0. And then the maximum is, in this case, is going to end up being not just the height, but also it's also influenced on by the bottom bracket offset. So the input max is going to be the cup height, so new height, minus the bracket bottom bracket offset. Bottom bracket offset minus twice the thickness of the bracket. And I think that was what we had. We already kind of went through all of these, and yeah, so the bracket, we already went through all these to kind of figured out the must be less than cup diameter or height minus bottom bracket thickness times 2. Yeah, so this is exactly what we had. I feel like we kind of wasted our time doing all pre-computing or pre-evaluating, or just thinking through all those constraints, because we're just redoing it right now anyways. Okay, I kept saying that I would do the camera, and then I haven't done the camera yet. Well, let's just test it. So we're slamming the cup up, and then now the bracket gap. Yeah, now we can make the bracket gap go up until that bracket reaches the very top. Perfect. Okay, let's actually do the camera now. I think I've been avoiding it because we're going to have to go into some more Babylon documentation. Maybe we should just go straight into just straight searching the Babylon documentation site, arc rotate camera. We have these really great articles that we can use. Well, first things first, I think right now it's orbiting the center of the world. We should have it orbiting the center of the mug. So let's start by changing that. Let's go to the on. This really shouldn't be in the on mug, like on the redraw mug function, but it's okay because when we redraw the mug, we can get a bounding box on it. So new mug bounds, new mug dot what's the get absolute pivot point? What is that? Returns a new vector to the mesh pivot point. What coordinates? No. We should just compute bounding box, I think. No, bounding. Get hierarchical bounding vectors. This is because it's not a mesh. It's a transform node. So I don't think we have that bounding box convenience. Includes descendants, true. And then we don't really need a predicate because we want all the meshes. So we should get that. And then the bounding vectors is just going to give us a min and a max. And I think we just have to find the center point between those two vectors. Const center point equals. Is it going to give us those two vectors in? Yeah, it should give us those two vectors in the entire hierarchy under current node. It should give us the vectors in world space, but we'll see what happens when we play with it. So center point equals. Is there a convenience function? There should be for finding the center point. Yes, nice. Okay. Value 1, new mug bounds dot min, new mug bounds dot max, and then new camera dot set target. I think set target. Defines a new target as a vector or a transform node. Oh, you can give it a transform node. Well, if we give it the transform node, is it going to put it in the middle of the transform node? Well, or at the origin of the transform node? Fit within the new target. I don't know. I think we'll just give it a point, and then I think that might be the cleanest way to do it. Let's see what happens when we do that. Oh my god, we need to figure out this zooming thing too pretty soon. Okay, so we drew the mug. This is working like with the initial draw. Make the mug way taller. Yes, our camera is kind of following it. Let's make the mug way wider. Yeah, that's nice. That is working because now we're actually pivoting about the center of the mug. Then let's play with the brackets to see if like it captures. Yes, that's really nice. So now we're kind of moving. Now we're kind of moving with the mug as it changes size. This is kind of, it's so hard to just leave the mug in like an invalid state. Every time I change something, I want to like go and change everything else. Okay, that's okay though. Um, let's tackle the camera situation with the panning and the zooming speed. Can also be handy. Zoom to max location, no. Wheel delta percentage. Yeah, this is what we want. We know exactly what we want. Wheel delta percentage. Let's go back into VS Code, come up to where we're defining the camera. Maybe we could do new. Okay, no, because everything is hard to rotate camera. There we go. Are these, where do we pass these options? Camera dot delta, what was it? The wheel delta percentage? It's just, no, it's not a function, it's just a value. What's the default? Probably 1. Let's do 0.5. See what happens. Yeah, that's better. I have a lot more control. Like I'm not flying through the object anymore. But as I get further away, I'm still able to fly all the way through it. I almost want it to be, oh, okay. I almost want it to just stop. Like, I don't want to be able to fly through it. That's not really a thing that you can do in most CAD applications. Well, you can fly through it, but then it shouldn't like spin around, right? Like when I fly through the object, yeah, I almost wanted to just keep a minimum radius, maybe based on that bounding rectangle. I think if we go back to where we set the new target in the redraw mug, we'll cluster all this camera stuff together. We'll set the point and then camera dot the minimum distance the camera can see from. No. There should be like a radius. Yeah, lower radius limit. Minimum allowed distance of the camera to the target. The camera cannot get closer. Yeah, that's what we want. Minimum radius distance equals, well, we want the distance between the center point and the maximum. So we'll just do the length of, okay, we'll do the length and then we'll add like a buffer. Maybe we'll just do the distance between the min and max, see like what that ends up kind of working out to. That could kind of make sense because we definitely do want to leave, you know, a buffer so that you can zoom. Actually, no, you don't want to zoom in too far. So we'll do the distance between the max and the center. That distance, the center point and the maximum. It doesn't matter, they're equidistant. New mode bounds. I guess we'll just do minimum because that popped up first on the suggestion. But again, the center point is by definition equidistant between the minimum and the maximum. Okay, let's see what happens. Huh. Okay, well it's still letting us get pretty close. A little bit too close, if I do say so. Like that's still way too close. And then when we slam the cup diameter, the way that we would really do this is to check to see if it's like we don't want the mug to get so close that it's clipping the edges of the scene. I think that would be like the cleanest way of doing it, but this is okay too. Like, I'm happy with this, I think. Because at least we're not flying through it. So yeah, that's better. I'm able to just sort of fly around the mug a lot more easier now, and I'm pretty happy with that, I think. I do want to change the ground size to adapt to the diameter of the mug. Let's go up to where we're defining the ground. Ground size. Yeah, ground size meters. Is there like an updatable? Yeah, updatable true. And then I think this ground needs to become a global thing. So we'll move it up. Move it up here and we'll say net ground. Babylon.ground. I don't know. Yeah, Babylon.ground mesh, I think. Is that what it is? Setup scene, create ground. Yeah. And then I think update, so in order to do updatable, we just set create ground again. In order to update the ground, we just use mesh builder.create ground, or maybe we do ground dot width, something like that. Ground dot width. No, because that's an internal property. Let's go into the Babylon docs for ground and see. Let's just look up update ground. Creating a ground. True if the mesh is updatable. Let's go into this example. No, it's not really helpful. Yeah, I think if we set updatable to true, we don't update the values themselves, we just set the variable to a new create ground, but that doesn't really make sense because that's going to create a new instance of it. Go back to that original search results. Update ground mesh. This might be it. No, this is just using like actual array buffers to update a mesh. Creating a tiled ground. Is there any mention of updatable? Might have to resort to DuckDuckGo on this one. babylonjs update ground mesh. No, we were already there. to update the vertices, are we? Maybe we'll create the new ground and then rip the vertices off of that and then pass that to the old ground. Okay, I think we're just gonna dispose the old mesh and then rebuild it every time. So sometimes you just gotta brute force these things and appreciate the power of modern consumer compute hardware. So we'll update this function and call it like, well, this is okay. We can just recall create ground, but we'll have, instead of having this ground size meters constant, be like this global thing, we can change it to, well, we can change it to a dynamic variable. But at that point, this is the only place it's being used. So at that point, you might as well just pass it as an argument, unless we want to access it somewhere else in the future. So it's okay. We'll update it in this as an argument to create ground. But then we'll also store it as a variable just in case you want to access it somewhere else. Ground size meters. And then we'll just do ground size meters equals ground size m. And then when we create ground, we'll do 0.5. And then we can just recall if the old ground exists, we'll have to get rid of it, so we'll do that as well. If ground, and just use a truthy statement, because if it's null or undefined, it'll be falsy. If ground dot dispose. And then we can just recall create ground in drawcup and redraw mug. Const new ground size equals the distance would be the min and the max, I think, maybe plus like a 10% buffer. So we'll do babylon.vector3.distance. We should call distance once and then divide it by 2 for the lower radius limit, because distance is an expensive function. So we'll just do bound distance. We would just do bounding radius, or bounding diameter actually. We'll do that between the new mug bounds and the max. Or we could just multiply that other value by 2. But it's okay. We don't have to prematurely optimize this. So the lower radius limit is now going to be half of the bounding diameter. Let's divide it by like a little bit less than 2, just so we have like a little bit, just so we can get like a, actually no, 2 is okay, we don't, that'll just let us get a little bit closer to it if we just divide it by 2. New ground size is the bounding diameter time, because add like a 1 like a 10% buffer, and then we'll say draw ground. Or was it create ground? Yeah. New ground size. Okay. Okay, so the ground size is starting out pretty teeny tiny because the mug is small. But then if we make the mug bigger, our ground is now getting bigger. And let's see if we make the bracket. If we slam out the brackets, the ground is also getting bigger too. So that's good. It's not getting quite big enough, which is interesting. I'm not sure why. Because the bounding diameter should encompass, there should be like the midpoint and the max point should be like somewhere over there. I'm not sure. That's it's good that the ground isn't getting bigger when we increase the height. Let's see if we increase the bracket gap if the ground gets bigger. No, it doesn't. So that's good. I mean, it should only be getting bigger if it's actually getting bigger on the XZ plane. Okay, this is getting pretty close to usable. It's still, there's still some constraints that need to be, but there's still some parameters that need to be constrained. Where are we on time? Where are we on time? We are 7 miles in, 30 minutes in. Good, good, good. This is supposed to be a 2-hour run, so I think we're doing pretty well. I eventually will just port this to a little like applet on my website, but for now I'm not going to bother too much with styling these just because we don't have a good styling setup on this little like, just on this little Babylon development framework that we have going, or this little Babylon development bench that we have going. There are no styling utilities really. I want to be able to input these numbers though as like number inputs with little arrows on them. So instead of having a span here, we should change this to an input. We'll do input type number. So input type equals number, and then I think that should automatically add those little arrows to them. Yeah, it does. I don't know, why isn't that value in the input? What's going on? I need to reload this. Oops. Why is this value out here? What's up with that? Oh, the ground is getting bigger when I change the height. So really what we would have to do to make sure that the ground, well, okay. We actually don't, sorry, this is not really necessary, but if we go to redraw mug, you can just make the new ground size equal to the ground diameter. Or sorry, the cup diameter. So cup diameter dot outer diameter plus twice the bracket because it'll extend on both sides. We can do, actually we'll do this. We'll do the cup diameter, cup params dot outer diameter divided by 2 plus the bracket extension. plus the extension length, and then we'll multiply all of that by 2. And that should be like the right ground size to accommodate, to fit the ground in the bracket perfectly. So if we increase the size of the bracket extension, right, the ground should fit that perfectly. And then if we increase the height of anything, that shouldn't affect the ground. And then if we increase the diameter of the cup, then the ground should fit that. So that's a lot better than using that bounding box method. Okay, that's a nice little fix or a little improvement, but we have to figure out why. Oh, right, because that's not how inputs work. That will no longer be, that just becomes another V model. And then we also want to redraw the model when the input changes. And we also want the same minimum and maximum. So really we can really just copy this top part and change the type from range to number. And then yeah, and then we can just kind of like also do this, but that's not doing anything, is it? Or is it just too slow to see? Yeah, that's not changing anything. What's up with that? Is it because it's not, like, for an input, do we have to press, like, enter or something? No. That's interesting. When we change this, when we move the slider, it does change the value inside the input, which makes sense. But when we change the input, at input, or at change, is it, maybe we should do at change. No, it doesn't like that. No, not liking that. This is why I don't really like V-model, because this would be so much easier. Maybe we don't really need a V-model here. Well, we do, because when it changes, we want to update the value as well. I'm tempted to just get rid of V-model on all of these inputs, and then get rid of all the watchers, and just have functions that are called when the input changes that update the value. Let's see if let's see if these minimum and maximums are influencing functionality at all. No. And when the slider isn't moving when I change this value. Like if I go to 2 and change this to 200, it doesn't move the slider. Okay. Now I'm thinking about whether or not it's just trying to troubleshoot this V model thing because I'm really not that familiar with it. Or it's it. No, because I'm using the type number, but maybe I need to cast it to a number. I don't know. But the thing is that like I can tell that job draw bracket is being called, or redraw mug is being called when I make these changes. It's just not. It's not actually updating the ref for some reason. It looks like the whole V model thing isn't working on this number type input. I'll read the docs for maybe a minute or two, and then if there's no clear answer, if there's no very obvious answer, use vbind. In addition to using vbind, always combine the input to non-string values. Where's vbind coming in? Let's look up. Let's do a DuckDuckGo on vmodel 2 inputs. Vmodel 2 input elements. Let's go back to that. Vmodel with 2 input elements. Multiple vmodel bindings on a single instance. No, the same component, no. I don't know what's going on, guys. I think we just go back to that. I'll do one last thing, which is I'll look at part of me thinks that it could be because there are multiple types of input. I'll do one last thing, which is I'll just modify this playground, and then I'll see if it works like that. It does work in this case. Input type equals number, and then let me see if that let me see what happens with this. Yeah, it's different input types, and that's what's killing it. So it looks like vmodel doesn't work across different input types. That's interesting. Let me just DuckDuckGo that to see if that's like a thing. Vmodel different input types. Yeah, I mean, it looks like just super cursory. I'm not seeing. Oh, there we go. Different input types. You can easily extend the custom input component to include additional features like validation. Different. No, that doesn't. It looks like that's not like immediately or just very obviously documented. I'm sure. I'm sure somewhere in the documentation there's something that makes it clear that it won't work across different input types. But in this case, we want different input types. We have our form, and we have our slider, and we have our slider range type, and then we have our number input type. So the whole V model thing isn't going to work, I think, and we're going to have to just do it the old school way. So we'll change these V models to value. I'll just do occurrence select, and then change that to $value. And then for all these input redraw mug, I usually like to do I usually do something called like handle cup height input, and then I'll just do the I'll pass it the event, and then same with this, like, well, the range input. Yeah, it's okay. These are going to be slightly different events, I think, but it's okay because they'll both have a value attribute that we can just grab. Let's try that. Handle cup height. Were we watching the cup height? Yeah, we were. So now we don't even need this cup height watcher. But we'll also make sure that we're defining all the functions in the same order as they are up there in the template. That way it'll just keep the code a little bit cleaner as well. So we'll do usually when I'm writing my own code, like in my own code production bases, I won't use function, I'll use const. So I'll do something like const. And then I'll do like event, and then I'll do like this, like an arrow function like that. But in this case, we'll keep it consistent with what we have. This is a really production code base, so we're not too worried about style and consistency. So we'll just write function, and then event, and then we can just do like a generic event interface. And then does that have a value? No, it doesn't. We should do an input event. Event.target.value, I think we can do. Okay. I do not want to do separate handlers for the range event and the input event, so I think I'm willing to do something a little sketchy and just, if the value does exist, we'll just run it, event.target.value. And then we'll just ignore TypeScript, if we really have to. I think we can do, can't do an exclamation mark on it, right? No, we can't do that, but let me just try that, and then cup height input, the cup bottom thickness. Right, that's okay, we'll change that later. And we do need to actually change the value, so cup height input millimeters dot value equals event dot target dot value. let's see what happens with that. So yeah, that's not working as expected. So it looks like the dot value does exist on the target because it's an input element. So we'll just what's up with this input? You guys didn't see that, but these are working. Like this is working now when I slide this. When I update this, it is changing the slider, but it's not changing the actual object, which is weird. So let's see what's going on with that. Oh right, we're not calling the redraw_mug function inside the handler. So what? So let's do this. We'll do const new value equals event.target as input as HTML input element, I think. Yeah, HTML input element dot value, and that will make TypeScript happy, and then we can do equals new value type string. Oh, this is a string. So we'll just do parse float new value. And then we'll do, well actually no, we should parse the float here because, no, actually we don't have to. We'll just, and then we'll do redraw_mug. Right, because that's what we're calling, yeah. And then we'll do redraw_mug. Oh god, now you guys can see what I was just doing in VS Code. What I just did is updated this function. So now we're grabbing the value by casting the event target as an input element, parsing that float into a number, even though I think it already would have been a number, and then we're redrawing the mug. But before we redraw the mug, we should also, if we look down here, this watcher, we'll start getting rid of these watchers because we don't need them anymore. We can set the cut bottom max. So after we redraw the mug first or before or after changing these constraints? Probably after. So now we'll do, update dependent parameters. Cup bottom thickness dot value equals cup height input dot value, and then redraw the mug. Update the mug. Okay, so that's what our handlers will look like anytime any future input changes. We need to create a handler like this for all 16 of the inputs. Let's just see. How many do we actually have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, it's 16. Wait, is that 16? No, there's actually 15. So there's 15 inputs. So let's do that 15 more times. But let's just make sure that that was working. So, oh yeah, another thing that I want to do is like on the initial scene, on the initial drawing, I want the camera to be like kind of in a reasonable position. But yeah, that is working, and I can, if I change this to like 400, I need to debounce. I need to debounce these inputs, I think, or maybe I shouldn't do it on input, but on. Yeah, I should do it on focus on blur. So instead of, for the number input types, I'll change this to blur. Focus event. That is annoying. Maybe I'll change it to on enter then. And just no. Maybe I could just do event dot. Well, it should still have a target. So maybe I'll do event input event for focus event. So they should both have a target attribute. And then let's fix the thing with the camera on the initial load. So it looks like on the scene setup function, we have something that looks like setup scene, and then, or no, it's when we mount it. Yeah, it's when we mount on mounted. Looks like we redraw the mug. We create the ground, and then we redraw the mug, and then we should have something that's like, we should have a function called position camera on mug. And then let's just write that function. Let's move that function to the bottom and just function position camera on mug. Let's mug parent. So we'll just find this. It's not super clean, but we'll just, the scene doesn't exist, just return. And then we'll do const mug equals scene dot get mesh by name, and then it's called mug parent. And she's not a mesh, the transform node, right? Yeah, so can we get transform nodes by name? Yes, we can. Mug parent. Alright, so we'll get the mug parent, and then we'll do the whole thing with the bounding box type thing on the parent. So we'll do set target, set radius. So mug bounds equals mugs.get hierarchical bounding vectors, bounding diameter. Oh right, if you can't find the mug, just return. The mug bounds, bounding diameter. And then we do also want the center point. So we'll set the target to the center point, and then we'll set the camera dot radius equals bounding diameter. I think that's reasonable. And then let's go back to the Babylon documents on the arc rotate camera. Go back into the deep dive on the arc rotate camera. We want to be somewhere around here, like somewhere along with beta. Also equals 0. So we can make alpha 0. Then we want beta to be like pi over 4. We want to be like right around here where this little theta label is. So we'll have alpha be pi over 2 and beta be pi over 4 maybe. We'll play around with that. Oops. Camera dot alpha equals math dot pi over 2. And we said beta should be pi over 4. We'll definitely have to just play around with this to see. Oops. What's going on here? Oh, oops. Okay. That's a little bit better. We want to be like a little bit further away though, right? So maybe we'll do the diameter times 2. Yeah, that's a little bit better. I think we want to be like a little bit further down. So we should set the beta to be, well, let's leave the alpha at 0 and let's set the beta to be like pi over 5. No, I like the alpha at pi over 2. And then I think this should be like, well, we want it to be less than pi over 4, so we want it to be more than pi over 4. Yeah, we want it to be more than pi over 4, because that'll move us down close to the ground. I like that. I like that. It would be cool if we could slide over a little bit like this. So we should set the alpha to, do you want to bump it? Do you want to, yeah, we want to bump it by another pi over 4 maybe, so plus math dot pi over 4. We'll add or subtract that depending on which direction we end up rotating in. Oh, the wrong direction. That's good. I like that. Maybe rotate a little bit less. So math dot pi over 5. Yeah, I like that. So that's nice, because now every time we open the scene, we're just like looking at the cup in like a more reasonable way. And then we can rotate around it and zoom. Should we set a maximum? Yeah, we should, because then the cup, otherwise the cup will just disappear. So when we redraw the mug, we're setting the lower radius limit, we should set the upper radius limit equals maybe bounding diameter times 5. That could be reasonable, right? Yeah, and then if we just increase the size of the mug, yeah, I think 5 times the diameter is like a decent distance so we don't get completely lost. And then I think we lost, why did we lose reactivity on all of these? Is it because of the input thing? Let's see why we lost reactivity on all the inputs. I don't think we changed anything else. I'm still calling redraw mug. Yeah, redraw mug is still being called. Oh, that's interesting. We lost reactivity on all those inputs. Let's see if it fixes it when we update it to the new way of doing things. So, right, instead of, oh, it's because we changed it, we got rid of all the view models. We did that find and replace on the view models. That makes sense. Okay, so we do have to actually update all those now to get everything working again. So that's the value. The input was the, well, we have to change this to handle cup diameter input, and then pass it the events. And then this is the same instead of a range, it's a number. And then we'll come down here and we'll create a similar function. We'll just copy and paste the function here. And say this is called handle cup diameter input. And then cup diameter input. Copilot will be picking up on this so fast, and we can get this done. We get this done in a fraction of the time that we're doing it right now. But this is a strict no AI challenge. So what we did is also update the only nice thing about the watchers was that these that they ran immediately, so that we didn't have to update, like we didn't have to make sure that the constraints were all starting out in a valid state. We could move these dependent parameter like changes to a different function. We could just have a function called like update dependent parameters, and then we could just call that every time any value changes. And then we could also call that once at the beginning. But yeah, now the diameter is working. Should we like have the camera zoom out? Well, it kind of does, if the minimum Z changes. But no, it's okay. I kind of really want to make the camera zoom out though. Like if we're way over here and then we increase the diameter, it's zooming out if it falls within the minimum Z, but it's not quite zooming out enough to actually see the whole thing. So we should do something like this. We should say, when we update the cup, when we redraw the mug and we're moving the camera, we should say, what did we do in the function camera.radius equals bounding diameter.2? So we should say if camera.radius, over here we should say, when we redraw the mug, we can say if camera.radius is less than bounding diameter times 2, camera.radius equals bounding diameter times 2. And then that way, if we slam up the height, the camera will zoom out. And then we'll also actually kind of zoom down in if it's within the minimum. If camera.radius is greater than that's okay. So this is looking kind of nice because now the camera is kind of like moving around as needed to accommodate the new mug as we change it. Let's get rid of these little axes hoppers. Axes viewers. We can hide the main one. We don't really need that. And then there's like a couple more that we created, and we'll just comment them out. Okay, that's all of them. So yeah, we got rid of all the axes. I kind of want to play with the light now. So we should, when we make the camera, we should, when we set up the scene, we should add a function to the camera that watches when it moves. So camera.onViewMatrix change observable dot add, and then we'll define a function. We'll say handle camera view matrix change, and this is also going to be nice because I want to get rid of the continuous render loop and we should only be rendering as needed, because like right now, for example, nothing is changing in the scene, and it's still rendering at 60 frames per second, recomputing everything, happening in the scene to redraw the scene every 60 times a second, which is a lot of unnecessary load on the computer. And then we'll just, end that. And then I think, do we need to bind that, or so? If it's a function, so we'll do, we'll add that towards the bottom again. And we'll do function handle camera view matrix change. And then when the camera view matrix changes, we want to move a light. We want a second light. We should come up here and say like headlamp or headlight or camera light. I think that would make more sense. So where are we kind of defining? Yeah, so let ground equals ground mesh. Let camera light equals babylon dot. What are the different types of lights? Spotlight. I think that's what we want. Spotlight is defined by position, direction, an angle, and an exponent. These values define a cone of light starting from the position, emitting towards the direction. The angle and radius defines the size of the spotlight's conical beam. Okay, I think we might actually prefer directional light, because that seems like a little bit unnecessary to have to like define the whole cone of light. If we just have like a directional light, it's just one big wall of light going towards the target based on the direction of the camera, that would be enough. So that camera light equals babylon dot directional light. Why is that blue? Why is this green? Is this a class? Oh yeah. Oh yeah. We're just defining the type here. There should be no equal sign. And then we'll call the ambient light babylon dot ambient light, right? Is there? No, that doesn't exist. What's the main light that we were using when we set up the scene? Hemispherical light. Okay, now when we set up the scene, we'll create two lights. We'll make this one the ambient light. And then we'll make a, we'll make the camera light equal a new directional light. What are the arguments that we have here? The name. Okay. We'll name this ambient light. And name this directional light. The direction doesn't really matter for now. Just because we'll do it in the negative z direction for now, but it's going to change when on every camera view matrix change, so it doesn't really matter. But babylon dot vector 3 dot forward, is that? Yeah. Well, we'll do backwards so that we're actually pointing at the thing. And then the scene is the default scene, we'll just leave that be. Okay. And then in camera light, in the camera view matrix change, we'll draw a vector between the camera target and the camera itself. I think we should already have that. Let's see. Const cam look vector equals camera dot up vector, no, camera dot, well, we could find the cross product between the up vector and the right vector, which we don't have. We don't have the right vector. Camera dot forward, get forward ray. What's the forward ray though? Let's go back to the Babylon documentation for the arc rotate camera. Let's look at forward. So let's look up for look or vector. We could always use the alpha beta, or we'll just take the camera position of the target and find the vector between those. I think that's going to be the easiest way. So let's go look vector equals we want to look at the vector, so we'll do the position, we'll do the camera position minus the yeah, I think we're supposed to do the no, we'll do the camera dot position dot subtract, and then we'll do the camera dot target, and then we'll change the directional light, the camera light dot direction dot set dot copy from, I think, yeah, dot copy from camera vector. Let's see what happens with that. That looks right, because when we're moving, yeah, and now we can actually see the bottom of the cup and it's not just completely black. Wait, no. Yeah. This is backwards. I think this is backwards. Yeah, because now everything is really bright when we're looking at it. But why is the bottom of the cup still black? That's what I don't get. There's definitely something weird going on with maybe the normals. I think like the normals on the bottom of the cup are just not right. But this light is way too bright, so we'll also do that ambient light, or do the camera light intensity, I think. Camera light intensity equals, and this should be a value from 0 to 1. So we'll change that to like 1.25. And it looks like that's just too low. It's getting washed out by the ambient light. So we'll also change the ambient light intensity. But yeah, no, 2.5 is just way too low. It's like it's getting completely washed out. Okay, yeah, that's nice because now we're getting like, you can actually see the light. And we're getting like actual reflections on the surface, which is nice. This is really bothering me though. The normals are flipped, I think, on the bottom of this cup. I think there's a utility where you can draw the normals and then we can actually see, but the normals will basically tell like the light rays which direction to bounce, and if they're flipped on the bottom of the cup, any light rays coming into the top just aren't going to bounce off at all. So I think that might be the root cause of the issue. But it would be difficult to identify that for sure. And it would be difficult, well, it wouldn't be difficult to identify for sure because we could just draw the normals. It would be difficult to pinpoint that exact surface and then correct the normals on it. But what happens when we change the bottom thickness? Oh, right, we have to update all those functions. Okay, so now that we kind of have like the cameras and the lights working pretty well, let's go through all 15 of these changes and fix them. All 15 of these inputs and fix them. How are we on time, by the way? We're an hour and a half, we're 18 miles in, so we're pretty much coming up to the end. I kind of want to take a break, but I also just want to power through this. Let's power through all 15 and then we'll end the stream there. And I think that once we power all through 15, we're going to kind of have to do the dependent constraints between the parameters as we write the handler functions for the input changes. So I think once we do that, we'll be at a good stopping point for the whole live stream. And that'll pretty much be like the end of it, because we can always add more cool features. We could add a scale to the side to show the dimensions. We could fix this whole messed up normal situation with the bottom of the cup being completely black. We could add an export feature, which I will do when I port it to my website. But for now, I think we're in a decent place. So let's just power through all 3 of these and write the handlers and fix the inputs. So inputs, I'll just go through and I'll write all the function names. Handle cup wall thickness input. Yeah, I'll do all of them at once. Handle cup bottom thickness input. This is handle bracket and width input. I didn't go rock climbing today, so you could probably tell I'm typing a lot better than I was yesterday. Handle bracket extension input. Handle bracket draft angle input. Copilot will be picking up on this so well. Handle bracket thickness input. Oops. Handle bracket cutoff input. Handle diameter input. What? Oh, handle diameter input. Handle diameter input. It's always a little bit tricky when you've got similes going on in your code. Handle offset input. How many more of these do we have? 4. Handle length input. Handle bottom bracket offset input. Handle bracket gap inputs. handle, bottom, bracket, handle, offset, input. The similes just get the names feeling really ridiculous, but they do kind of make sense anyways, so it's okay. Alright, so now we've got all those handlers set up. I'll just come down here and create the empty functions in the right order. We got cup wall, cup bottom, and bracket end width. Cup wall, cup bottom, and bracket thickness. And all of these need, I'll come back in and I'll copy and paste the arguments for the same for all of them. Oh, the bracket end width, not the bracket thickness. Okay. Bracket extension, bracket draft angle, bracket thickness. Function handle bracket extension. What was it? The function, the draft angle. This threw me off. I feel like I've misspelled extension multiple times. The extension, the draft angle, and the thickness. And then we've got the bracket cutoff, handle diameter, and the handle offset. There's the handle diameter, and then the last one was the handle offset, I think. Handle, offset, but handle, bottom bracket, handle, offset input. That would have been an okay name too. Then we got the handle length, the handle bottom bracket. Oh right, the handle offset is the distance from the edge of the cup to the handle. It should be more like a gap. Like gap would have been a better word than offset, but it's okay. Handle length input. We've got the handle length, the bottom bracket offset, and the bracket gap, and then the last one is the bottom bracket handle offset. So function handle length input. Was it the offset? I already forgot. Yeah, it was. And it was the gap in the last one. And the last one was the bottom bracket handle offset, but I already copied it, so good. Okay, so that's all the functions defined. We shouldn't be getting any red lines on those. And then in terms of the arguments, they're all the same. It's either focus event or blur event. Just copy that in. of wish I did a find and replace on it instead, but it's okay. We've got a couple functions with no arguments, so it wouldn't have been a completely clean replace all anyways. Okay. And now if we go to these should be reactive again, right? Or no, because we're not redrawing the mug yet. We're not doing anything in those handlers yet. So let's go back. And I'll just copy this in. These become numbers. These become number inputs, and we want these on blur, not input, so that we don't get the mug doing crazy things like in the middle of it. A lot of copy and pasting without AI. This is the reality of what programming kind of used to be like. I remember it well. I remember it well, and I do not miss it. But I'm also so used to it that I feel like I'm not like going insane doing this, honestly. It's just part of what it used to be like. I'm trying to think if it's still ever valid to kind of like program like this without using something like Copilot to just do all this copy and pasting for you. I can't really think of a situation where this would be like a good idea to just do this out by hand. Except for maybe the fact that when you're copy and pasting a lot, it gets you more attuned to like architecting your app or your programs in a way that you're not using all this kinds of repeated code. Like when you're copy and pasting a lot, it's kind of a hint that like maybe your whole architecture is a little bit messed up. In this case, it might really be. Like you could define these as, we could do like an array. You could have objects that contain like the min, max, the handlers, and then the value refs, and then we could render them in a loop. We could have an array of those and render them in a loop. That way, if you ever wanted to change the order, it'd be a lot easier, I think, to do it that way. So yeah, I think it is actually very valid to do things the hard way or not. I think it's valid to have done things the hard way and learn from that, because it'll make you a better programmer for sure. Okay, so those are all updated, but we still have to update the actual functions themselves. The cup height, we have to delete this watcher, so no. We already have the bracket extensions. We only had 2 watchers in place. 2 of them were the cup height. There are 2 watchers for the cup height. So, right, when the cup height changes, the bracket situation, the bracket gap changes. So let's go to the cup height handler and update that dependent parameter as well. And then I kind of feel like this parse float should be wrapped around new value instead of being done here, but it's okay. And that way we could just use new value in these updates instead of using cup height.value. Both are completely fine. Like using cup height.value is completely fine. It's just a little bit clearer when you're scanning the code. You can just say, oh, this is being set to the new value. This is being set to the new value minus this and this. But it's okay. So new value I'll just copy this portion and then get rid of this. And then when we copy and paste all this to the other functions, we'll just have to make sure to change that one value. So this should be bottom thickness input. This should be bottom bracket bracket and width. It should be bracket extension. It should be bracket draft angle. It should be bracket thickness. It should be the bracket cutoff, tangent cutoff. This should be the handle diameter. This should be the handle offset. Wait, no. The bracket handle offset. This should be the handle length input. This should be the handle bottom bracket offset. No, sorry, the bottom bracket offset. This should be the bracket gap. And then finally, this is the bottom bracket handle offset. And we've got one watcher here, the bracket extension, right? The bracket, the handle offset. Should be the extension length. So let's go to the extension handler. And then we'll fix this. We'll make sure that this is equal to the bracket extension. And then that takes care of all the watchers. So now that we won't need any watchers anymore. Any of the dependent parameters will be set in the handlers themselves. So that's nice. That's the way that I was going to do it in the beginning, and then I was like, let's just use vModels to keep it simple. And now here we are redoing everything. Okay, so now these should all be like reactive again, and they are, right? Yeah, the bottom thickness it's interesting. Yeah. Yes, there's definitely something wrong with the normals on this bottom piece. It could be a bug in the Babylon. Okay, so we should, I don't know if we should allow or disallow this, where it's like the handles go way, way past the end of the mug. Wait, you guys can't see this. Okay, so yeah, all of these are now reactive. What I was saying is, I don't know if we should let like the handle ends just fly out and become these like giant wings. I think we'll let it fly for now. Bracket thickness can go way up. I don't know what the maximum bracket thickness we do need to set a parameter for that. We do need to set the tangent cutoff, because the brackets need to be attached to the actual log. I think that should be like, that should be basic. That should be required. The handle offset. Yeah, because if the bracket cutoff is too large, the handles just aren't even attached to the mug anymore. Another cool feature you could add is like a little hand. It's like the same. It's like the rough size of like the average hand, so you could get just like a general sense of scale for what you're working with. Okay, so there's something going on with the normals in the CSG2 situation. I'm kind of wondering if, well, where are we on time? Because I'd be completely happy to leave it at this, to be honest. We still have 20 minutes. I think in that 20 minutes, it makes most sense to go through each of our parameters and nail down the other dependent parameters on it, which sucks because that's kind of the most difficult part. But we should. So the cup height, again, we're getting into the argument where it's like, yeah, this shouldn't happen, but also if the user wants to like adjust the cup height down to here, and then they later want to come in here and then lower the bracket length or the bracket gap, should we allow them to do that? Or should we say like you have to lower the bracket gap first, and then once the bracket is below the top of the cup, then you can lower the cup, right? Like, should we allow intermediate invalid states is the question. For the sake of this, I would say yes, because it's like, it's just more convenient and faster to edit it. If you want to know, hey, I want to slam the cup height down, let me just do that first, and then I'll come back and I'll fix the bracket to make it a viable cup or a viable mug. So I think cup height is like one of those unconstrained things, really. I'm still not, like, even though I just said all that, I'm still not completely convinced about what I said about whether or not it should be constrained. You kind of want to just think through that for like a second. I mean, it wouldn't be too much of a hassle to come in and say, okay, I want to lower the cup, then I need to lower the bracket gap first. I feel like there should not be intermediate invalid states, because for the sake of this demo, which is just a demo, right? This isn't like a real product. Then I just feel like it's better form for me as a programmer, as like someone designing this little parametric generator, to say it can only generate valid states, and you as a user need to use the inputs in the right order to get those states to work out. So let's do that. Let's go into the cup height. Let's say that the handle, the cup height, it can't go below the top of the handle, or the top of this bracket. So we would constrain it here. We would say new value, right? So we should parse the new value into a float here, because we're gonna check to see if it's valid. So that's annoying. We already copy and pasted everything, but so we can basically say like if, well, there's two ways of doing this actually. We could either check to see that the value is valid in the handler and then block it, or we could set the ranges as they change. So like when the cup gap changes, we can just set the range. Or when the bracket gap changes, we can set the range. So I think that kind of makes more sense because we have to do that anyways to give the usual visual feedback to the user to say, hey, this is where you can and can't set the value to. And then if we're going to do that anyways, it would be redundant to do that again to validate the values as they're coming into the handler. So I think that kind of double check is not actually a good thing. So we should come into the bracket gap. I think that's an assembly parameter towards the bottom. Yes. So then the update parameter, the independent parameter would be the height. We would say that the cup height it doesn't affect the maximum, but the minimum would now become the bracket offset, the bottom bracket offset. We do have to also run this when the bottom bracket offset changes. And I can already think of some architectural improvements because this will be the same. Yeah, each parameter should have a function called update min max. And when that parameter is affected by the change in any other parameter, we run that update min max function. Can we architect it like that from the get-go? I think we should. Like, let's just do things the right way. And it's also a cleaner architecture because we can kind of keep the handlers close to the parameter constraint function. So we can say function update cup diameter constraints. And this will have no arguments because we're just going to look at the actual values. So update cup diameter constraints. We'll say, sorry, not cup diameter, but cup height. Function update cup height constraints. So the cup height is constrained by the bracket bottom gap, the bracket thickness, and the bracket bottom offset, the bracket thickness at the bottom, the bracket gap. So we'll say that the cup height input minimum dot value is equal to the bottom bracket offset value plus twice the bracket thickness. And we'll do the bracket gap, so plus the bracket gap value plus twice the bottom bracket plus twice the bracket thickness. And then anytime those values change, yeah, things can get a little tricky though when, like maybe in this, you should have something that says if it's below the minimum, slam it to the minimum. If it's above the minimum, slam it to the maximum. That way, the values will automatically change. But then we can get risky into a point where if there's any circular constraints, we end up creating an infinite recursive loop. So we should hold off on updating these automatically and just kind of see what happens if the sliders get kind of stuck because it's already below minimum or already above the maximum, then we'll see how to handle that later. But the update height constraints, those are the height. The height is dependent on the bottom bracket offset, the bracket gap, and the bracket thickness. So in those parameters, in the bottom bracket gap, we'll say update cup height constraints. And then in the bottom bracket offset, we also need to update the cup height constraints. And then in the bracket thickness as well, right? It's kind of like, these constraints are sad because they kind of limit like certain things from happening. For example, if we come in here and we say, if we take the bracket gap, well, we can't do it anymore, but like, what if this bracket was really thick, and then, right, like this, yeah, exactly, like, what if the bracket was really thick, and it came up over the lip of the cup? That's a neat design. Like, that could be kind of cool under certain circumstances, especially if this was more, like, especially if the draft angle was slammed to 90, and it was just like this, and it had like a neat little lip. That could be cool. So again, like, there's kind of a sadness to putting these constraints on the design, because then you just limit what's possible. And this is technically constructible. This is usable. Well, if this handle is, let me make the handle longer. Like, if this handle is actually like longer, and maybe if the bracket extension, if the brackets came out a little bit more, like, this could be a cool cup, right? With like, this could be a cool mug with like this little extra lip coming off of it. I don't know, like, there's definitely a sadness to me in these. I don't know if sadness is the right word, that's a little dramatic, but like, there's something lost for sure when you start adding these constraints. And you kind of have to just accept that, I think, and move forward with it. So let's accept it, and let's see what happens. So we constrain the cup height, and now, wait, we can still slam the cup height below for some reason. Let's see what's happening here. Oh, right, because these aren't being run. The constraint updates need to be run once at the beginning in the initial state. So on the unmounted, we can say, we can have a function called like sync all constraints. Sync all constraints, and then we'll just run all the updates. So update cup height constraints. These are the only ones that the only functions that we've defined so far, so we'll just click those two. But yeah, you can put this somewhere in the beginning and just say like update or sync all constraints. And then that should now prevent the cup height from going below. Yeah, so now the cup height can't go below the handle. And then if we wanted to actually lower, we do need to constrain the bottom bracket offset as well. But now, if we want to make the cup height lower, we would have to either change the bottom bracket offset or change the gap. Change the bracket gap. We could move the back bracket gap down, and then now the cup height, we should be able to slam it even further down. Yeah. So that's working. Let's go back into VS Code. Update dependent parameters. Right, so the cup height, we want to change all these updates. So the cup bottom thickness input. Let's go to the bottom thickness. Where's that? The cup bottom thickness, and we'll add a function called update cup bottom thickness constraints. Whoa, okay. Sometimes I really just forget how to type. Update cup bottom thickness constraints, and we'll set that the only thing that the bottom thickness is constrained by is the cup height. So we'll say the cup bottom thickness is this. And then we'll say when the cup height changes, we do need to update the cup bottom thickness constraints. And then the cup gap input. This is where we're getting our first circular dependency. Update bracket gap constraints. Update bracket gap constraints, and then we'll actually have to write that function. Come down here to the bracket gap function. Update bracket gap constraints. This is a circular constraint because the cup height is dependent on the bracket gap, and now the bracket gap is also dependent on the cup height. So we're getting into those, and I think it would be really neat to crack the problem of having constraints, not having sliders slam against constraints, and rather having constraints update each other as they go. So for example, the cup height, we wanted to bring the cup height, but it was running into the top of the bracket. We could also lower the bracket at the same time. That would require a very well thought out graph of dependencies between the constraints. And then once we have that graph of dependencies, we would be able to follow the loop once instead of getting into this crazy recursive situation where the cup height is making the bracket go down, the bracket going down is making the cup height go down, and that's how you would get into a runaway situation with the constraints. If we had a graph of the constraints and the relationships, then we could actually make that work. And I think that could be neat to try and implement. I don't think it would be that difficult, but it would require methodically creating that graph of dependencies. But that looks good. This all looks good. Some of these are, let's go back down to our comments and see like what the constraints were. The height, this was indeed constraint. Well, there's no point in commenting that. It's all defined in the update constraint functions. Bottom thickness, right, the bracket and half length. Okay, so the bracket end width. I don't think, yeah, the end width is constrained to the diameter of the cup. So when the diameter changes, right, let's go through these one by one. So when we change the height width, yeah, right, when the diameter changes, we need to update the wall thickness constraints. So we can say update cup wall thickness constraints. And then the diameter also affects the bracket end width, because I don't think we want the bracket, again, like there's that, there's an element of loss when you're creating these constraints. we're sacrificing some potentially cool designs. But if we, I don't think the end width should really go past, because we don't allow a draft angle on the bracket less than 90. But we could have bracket draft angle less than 90, and then we could also have the handle go, the end of the brackets go past the diameter of the cup. But in this case, we'll eliminate that possibility, which is a loss, but it is what it is. It's more faithful to the original design intent of the cup that I had, so I give it a positive spin in that way. Update. So then we have to update the bracket end width constraints as well. So we'll come and define these two functions: the update cup wall thickness constraints. Where's the cup wall thickness? Update cup wall thickness constraints. This is a function. And then that's good. And then the bracket end width constraints. Function update bracket end width constraints. And then the bracket end width just has to be, the maximum is going to be the diameter. So bracket end width input maximum millimeters dot value equals the diameter now. So cup diameter input millimeters dot value. It looks like this is already being updated somewhere. No, it's not. That's weird, because where is this happening? The bracket end width. It really does look like this is already being updated somewhere. Oh, this is it. This is what's happening here. You can see that. I need to double check all of these. Yeah. So you can see that if I don't do value, this ref will just take on this ref by reference. So it's really important to put value when we're passing an initial value to a ref. Otherwise, it will just adopt that ref. And that's why it looked like that constraint relationship was already applied, but it wasn't actually properly applied. Okay. Right, and then really quick, let's do the rendering thing. Let's go to in redraw mug. At the bottom, when the mug is redrawn, we can say scene.render, and then on the camera view matrix change function, we can say scene.render, and then we can get rid of the rendering loop. What is this render function? Oh, okay. I see. So instead of running scene.render, we can just run that render function. And then now, okay. Well, now it's rendering properly when we change the cup, but it's not. It's not rendering when I try and move the camera, which is weird because the camera view matrix should be changing when I apply those inputs. Let me just log this to see. No, the camera view matrix isn't actually changing when I apply those inputs. Maybe if I go to the, maybe it only changes the camera view matrix on render. If I go to camera dot attach controls, and I pass it more. Use controls for panning mouse button. Use control for panning. Wait, that looks interesting. Sorry, I'm getting distracted, but let me just. Huh. Okay. No, we need to go into the Babylon documentation. And just say view matrix. How the view matrix will change on any input. What's going on here? On view matrix change observable. Maybe there's an on camera dot on input or on move. On projection matrix changed. I'm just gonna add like a little anonymous function to this just to see if this is changing on. Just to see if this is changing on inputs. No, it's not. On view matrix change, on ready, output render target, on ready, on projection matrix changed, on mesh target changed, on enable state changed. No. So that's interesting. Really thought that the view matrix would change when these controls are. Let's do a little quick documentation search. Yeah, this just does not work because we tried that and it didn't. Tell me if the camera is moving still or standing. This isn't working. That is not working for us right now because I'm doing that. I'm gonna try adding this as an anonymous function to see if there's something with the fact that I'm passing that function. No. It's almost like it's waiting for it to render. Like it's almost like the camera's like waiting for the render to actually change it to be matrix or something. I don't know. This is weird. I've done this before to render the scene when the camera moves. That's really annoying. I mean, I guess like a really crude workaround would just be to render the scene when there's dragging happening. Any dragging happening, just render the scene. I'm gonna do that. Oh, wait. Yeah, I'm gonna do that. I'm just gonna have it render whenever there's dragging happening. So I'll just add something called like let on drag listener, and then I'll do window dot add event listener drag handle drag listener, and then I'll set why is that returning void? It should be returning. Should be returning the listener ID, right? The other overlay. Oh well, I'll just pass it this function again, I think, and then I can remove it that way. Okay, let's go back down to the bottom. Again, probably not a big deal that we were rendering, constantly, but we can also get rid of all this like code that we saved as an example. We don't need it anymore. That was a weird little. That was a weird little like distraction to try and get the rendering working. Function handle drag listener render. The thing is that like render is now just gonna fucking render the scene. Oh, update camera. Maybe this should be false. Maybe update camera should be false, and then that way we'll. Let's see what happens. Well, no, because now the camera's not updating at all, so it should be true. Still not working. The dragging event listener isn't working. I think it's because it might be getting captured. It'll be getting like stolen by the inputs. Where's on mounted? Where's. Oh, there we go. window dot add event listener. And window is like the top dog that we could like attach the listener to. Maybe we'll just we'll render every time the pointer moves. Yeah, we'll just render when the pointer moves. Because it looks like the drag events are getting captured by the camera. And now we have to be careful when we render because you don't want to render, like, we might be rendering more than 60 frames per second, which we don't want. So we need like a simple rendering manager to just request the render. So we can do that. We can quickly implement that. We'll just have something called should render. We'll just set a flag up here. We'll call it that should render equals true. And then in the render function, we'll just say last render equals 0. We'll say if scene if right, we don't really need should render actually. We can just say if last if date dot now minus last render is greater than, and then we need like a let's go up and get rid of should render. We don't need that. Let's put last render, and then we should do let target render interval. You can actually set that as a constant. So const target frame rate equals, I don't know, 60 frames per second. So then const target render interval will equal 1 divided by 60. So target render interval milliseconds. Target frame rate FPS. And then target render interval milliseconds will equal 1000 divided by 60. And then we can come down here and we can say if date.now minus last render is greater than the target render interval, then render. Otherwise, we just shouldn't render because we already rendered recently enough that we don't want to overload the system. The problem now is that it's like we lose that cool, we lost panning and zooming, and we also lost like the whole the smooth, like when you after you pan it kind of smoothly, everything's like very jittery now. So that whole drag thing is not the move. I'm really upset that the camera view matrix change situation isn't working. I'll fix that later when I actually put it onto the website. I don't know, maybe that provided a little taste of what it's like to render things as needed. rendering manager already in the scene. What were you even doing? Wasn't there a rendering loop or something? Or was that just part of like the top Babylon instance? I forgot what we even deleted to get the rendering loop going. Oh, was it the engine? Why is it doing that? Yeah, engine.run render loop. Let me just pass it the function. And then we should probably get rid of this, all this. Okay. Well, now we're back to where we started and nothing actually changed, so that's good. We still have to, and we're over time, and we have to run, and we still have to do all the constraints. So let's just quickly do those constraints, and then all the rendering stuff, I'll do that when. I'll do that when I port this to my website. So the bracket extension is unconstrained. You can make the brackets as long as you want. The draft angle input, right? We don't want this to happen, do we? Well, I don't hate it, honestly. So let's allow that and just keep it simple. Where is it? Sorry, but there's still something that's printing dragging. No, I need to reload this. That's better. Bracket thickness, yeah, that needs to be constrained. So the bracket thickness needs to be constrained such that the top bracket doesn't go over the top edge of the cup. So let's think about that. Let's go to the bracket thickness. Handle bracket thickness. Right. Okay, so let's create a function. Function update bracket thickness constraints. And then this is going to depend on the height of the cup and the bottom offset of the bracket. So basically the bracket thickness, the maximum bracket thickness there is, the minimum should just be like 1. Bracket thickness input maximum dot value. It should be constrained such that it can't go over the top. Which is interesting though, because right, so it has to be less than the bracket gap equals how much room do we have for the bracket? That's the question, right? the amount of room that we have for the brackets is equal to the cup height minus, we could say, cup height input milliliters dot value minus the bracket gap input milliliters dot value minus the bracket bottom offset. And then it's going to be half of that. And this was never even a ref, so we have to fix that. Then we actually have to, this is dependent on the cup height, bracket gap, and the offset. So the cup height the bracket gap, and definitely the assembly parameters towards the bottom. Yes. And then the offset, the bottom bracket offset. Then we do need to handle bracket thickness constraints. We need to, well, I'll just change the cup height to quickly update the constraint, and then we can quickly look at whether or not that did the right thing. No, it didn't work. Let's go back to the handle bracket. Bracket thickness constraints. Bracket thickness input max. Well, let's just make sure that that's actually being used in the correct place. No, bracket thickness. Yeah, that is actually being used correctly. Oh, the function wasn't actually being called. I copied and pasted it wrong. So if I change the cup height, the bracket thickness should now not be able to exceed this. Yeah, that does work. It does work, but it's not flush for some reason. And this focus thing is annoying because like it should automatically update when I press on these clicky things without having to unfocus the input. Oh wait, yeah, there's definitely something like a little bit off with the bracket thickness. Cup height minus the bracket gap. Minus the bottom bracket. Yeah, it should be half of that. So I think there's an issue with the rounding going on. It's like dividing this by 2. this isn't right, but okay, so that's kind of working out. Just looks like for certain values it rounds it. Like since these values are rounded, right? So round to the nearest millimeter. So I should probably run a ceiling, or like anytime I'm working with dividing it by 2, it gets a little bit tricky because these values are rounded. So I can't, like these are integers when I'm putting them in. So I can't, the sliders, I can update the sliders, maybe get them to work down to like 0.1 millimeter intervals, and then that will, because these sliders and these clickies, if I change this to 19.5, yeah, like that's fine, and it takes that value and that works well. But these numbers, these up-down arrow buttons are only going to be integers, and the sliders have a granularity of an integer, so it gets a little bit weird. But yeah, I think that's, I mean, there might be a couple more constraints in here that I don't really want to get into right now. Yeah, the bracket gap constraint needs to be fixed. I'll just do that one. That'll be the last constraint, and then, oh yeah, update bracket gap constraints. This needs to change when the bracket thickness changes, does it? No, it doesn't. That's one. Okay. So I think that's good. Like I'm pretty happy with that. Before I post it on my website, I'm gonna figure out the UVs/normals on this bottom surface of the mug. I think that's kind of annoying. Well, the bottom thickness. We might be getting into a circular thing. There's definitely a bug happening because when I increase the bottom thickness past, like the bottom thickness constraint isn't working. Let's look at that. Update bottom thickness constraints. Cut bottom thickness input max equals cut height input millimeters dot value. Yeah, that should be right. Looks like that's being used correctly in the template. Is this being called when the cut height changes? Yes, it is. I think part of it is the sync all constraints. It's working fine, yeah. So this sync all constraints really needs to contain all of them. Okay. Cut bottom thickness constraints. Update cut wall thickness constraints. Update bracket and width constraints, update bracket gap constraints, update bracket thickness constraints. I think that's all of them. 1, 2, 3, 4, 5, 6, 7. Yeah, that's all the constraints to sync, and then we shouldn't be getting those errors anymore. Yeah. Okay. So I'm pretty happy with that. I think that's a good place to leave the project from a live streaming standpoint, because we just got all the main components done. And then let's just sort of detail work to work out some of the kinks on the rendering and the optimizations, putting in some materials maybe. But those are all sort of not related to the core project, which was to get a parametric object written in Babylon from scratch. We should start playing with it though, just to get some satisfaction out of the project. So let's increase the bracket extension. Make these brackets a little bit longer. We'll increase the handle offset to move the handle out. We'll increase the bracket gap, in which case we do need to increase the handle length. And we can create these cool kind of like buckets. Let's increase the bracket end width, make the bracket a little bit wider. Let's increase the cutoff, the tangent cutoff, to get a flat section along the edges, and then let's increase the draft angle, get like a wider handle. Maybe not that wide. And then we'll lower the cutoff a little bit. Lower the cutoff a little bit. Lower the draft angle a little bit. Yeah, I like that. And then let's lower the wall thickness a little bit. Yeah, that's cool. Yeah, I mean, that's pretty awesome. Like, I'll also just kind of think of the right diameter, right dimensions to get a mug that would actually be good to use. And then I'll plug those in and build it. Either just 3D print it, or 3D print each of the separate meshes and then glue them together or something. And then maybe do this handle. Maybe I will also update it so that the handle creates a hole through the brackets so that I could 3D print those and then use like a shaft, like a piece of, I don't know, like a 10mm wooden dowel or something like that. Oh, but yeah, that was a long stream. I think in total it might have come out close to 10 hours to do this, which is pretty ridiculous. But it was a lot of fun. And it'll probably be a couple more hours to clean it up and put it on my website. But the next stream might be happening soon. I actually don't know. I have a lot of other work to do, and I don't know if I'll have time to do like a fun project for my site. But I will be doing a write-up on this as well. I think that will be the more interesting part. It'll condense 10 hours of work into the actual important parts.